So sudden stops is a typical phenomena often observed in emerging economies, which is characterized by the drastic current account reversals and resulting deterioration of the economy. So countries countries lost access to the international financial market, and they cannot borrow anymore, and capital inflow stops, and because of that, domestic economic activity deteriorate. So there are a lot of literatures on sudden stop. So why sudden stop happens, how can we explain the dynamics of sudden stops, and what is a good policy intervention for that. But here we try to add some new insight, focusing on the beliefs, people's beliefs for losing access to the international financial market, or focusing on the beliefs for the people's belief for current account reversal. Why beliefs? We have a story which we want to tell. So we observe that the countries with high frequency of current account reversal tend to experience the huge event of sudden stops. So that these countries, current account reversal often happens, but these current account reversal do not lead to the sudden stop. And the opposite is true. Countries with low frequency of current account reversal tend to have relatively many periods of sudden stops. Let me be more clear. So here we visualize the event of current account reversal for 4 countries: Venezuela, Uruguay, Brazil, and Argentina. And in the green point, this is a point of this is a period of current account reversal. So, for example, Venezuela experienced 8 events of current account reversal during the period of 1970 to 2019. And in addition to the green one, we have red one. The red one is a period of sudden stops. So, in this period, current account reversal happens, and it results in the severe sudden stop crisis. So in red period, current account reversal happens, and the GDP falls in the significant magnitude. So Brazil and Argentina experienced 3 episodes of current account reversal, and 2 of 3 leads to the catastrophic sudden stop crisis. So the blue one is just normal time. And what we observed is that in the Venezuela and Uruguay, there are a lot of current account reversal, but these current account reversal didn't, result in the severe sudden stop crisis. But in Brazil and Argentina, there are only 3 current account reversal, but 2 of 3 result in the severe crisis. So our story is that people have different beliefs for current account reversal. So, for example, in Venezuela and Uruguay, because they experienced a lot of current event of current account reversal, people believe that the current account reversal comes again in the near future. So they try to prepare in a precautionary manner. But in Brazil and Argentina, because they do not experience a lot of current account reversal, they do not believe that this current account reversal come again. So because they do not prepare in the precautionary manner, and once current account reversal comes, it has a bad effect. So we try to explain the pattern with high frequency of current account reversal and less probability of sudden stop, or less severity of sudden stop, and low frequency of current account reversals, and more high probability of sudden stop and more severity of sudden stops. So to explain this pattern, we use small open economy model with collateral constraint, occasionally binding collateral constraint. This is good laboratory for our purpose because this model is can replicate the dynamics of certain stops. So when collateral constraint binds, the economy cannot borrow anymore, and capital inflow stops. So this captures the situation of the current account reversal and possibly the situation of certain stops. We investigate how do the beliefs for the stop of capital inflows or the binding of collateral constraint matter. We show that the high beliefs for the binding of collateral constraint motivate the more saving. And with the high precautionary saving coming from the high beliefs for the binding of collateral constraint allows more capital inflows during the episode of current account reversal. And this leads to the less probability and the severity of certain stops. And to do our experiment, we somehow model the people's beliefs for the current account reversal or stop of the capital inflows. So we utilize the regime switching model, rational expectation DSG model, and we model the regime of normal time and the regime of the current account reversal. And the switching between normal regime and the current account reversal regime is governed by transition probabilities. And people form the rational expectation for each regime depending on transition probabilities. So as if the transition probability for going to current account reversal regime is high, people believes that the current account reversal comes with higher probabilities in the next period. So so by utilizing the regime switching model, we model the expectation or beliefs for the another regime. We show that high beliefs for the current account reversal alters the adjustment to the negative income shock. So in response to the negative income shocks, typical adjustment is that people borrow more, people increase the borrowing to smooth consumption, and the current account deteriorates. This is what intertemporal theory of current account suggests. But when the beliefs of the current account reversal is enough high, this adjustment can be opposite. When under the high beliefs, following the negative income shocks, people decrease the borrowing, and the current account improves, and there's no consumption smoothing. And as a result, on impact, the impact of the negative income shock becomes high, and the economy becomes more volatile. But because, so under high beliefs, once the current account reversal realizes, high precautionary saving due to high beliefs mitigate the reversal. We will be more clear in the later, but so the all numerical analysis are conducted with lies. So the model is a very simple small open economy model, tradable or non-tradable goods with endowment. And we have occasionally binding collateral constraint. So the household borrowing from the rest of the world is limited to some fraction of current income of the household. Under this environment, following the negative endowment shocks, collateral constraint endogenously binds. And this situation captures the situation of the loss of access to the international financial market. And when constraint binds, the current account capital inflow stops and the current account reverses. and possibly leads to the sudden stops. So household problem, household maximize utility by choosing the consumption. The aggregate consumption is coming from tradable consumption and non-tradable consumption. And yeah, in each period, household get endowment income, which are given as endowment, YT and YTN, and non-tradable endowment YTN is evaluated as the relative price PT. So this is the relative price of non-tradables in terms of tradables. And in addition to this income, people can borrow from the rest of the world, DT plus 1 at the interest rate R. So positive D, T plus 1 is borrowing. They use this income to consume tradable goods, non-tradable goods, and paying back the yesterday's debt. And yeah, and to pay the debt adjustment cost. But this debt adjustment cost is just to induce the stationarity for this small economy model. And collateral constraint is given by this. So today's level of borrowing from the rest of the world must be smaller than or equal to kappa fraction of income. YTT plus YTN evaluated at PT. The optimality condition, yeah, so marginal utility of consumption and relative price and relative demand when non-tradable goods is relatively more expensive than tradable goods. People consume more tradable goods and less non-tradable goods. The Euler equation, yeah, Euler equation. So what is important is mu. Mu is a Lagrange multiplier on the collateral constraint. So when collateral constraint binds, mu t can be positive. And in this case, when mu t becomes positive, the level of borrowing must be smaller than the optimal level. So this is the binding of a collateral constraint to capture the situation of the stop of capital inflows or current account reversal. Market clears for tradable, non-tradable goods and tradable goods, and both endowment, tradable endowment and non-tradable endowment are given by this bivariate process. So now how do beliefs for the current account reversal or binding of collateral constraint matter? This is the Euler equation. Suppose that in period T, collateral constraint is not binding. And now we iterate the Euler equation, one period. And we have this equation. And as long as the binding, future binding is expected, we have this expected value of mu t plus 1. So as long as binding can happen in next period, people have a more marginal value of saving. And as the probability of binding and the beliefs of the binding becomes higher, this expected value of mu t plus 1 increases. And so people have a more incentive to save with higher beliefs for the binding. And so the people accumulate more precautionary saving. Now, now suppose that the collateral constraint binds in period t plus 1. Now the level of borrowing is determined not by the Euler equation, but by the value of collateral with this equation. So dt plus 2 is the level of borrowing in period t plus 1. So because constraint is binding, this must be equal to the kappa times this income in period t plus 1. And given exogenous yt and yn, the level of borrowing is determined by pt plus 1. This pt plus 1 is given by this equation. And we can see that PT plus 1 is decreasing in yesterday's borrowing. Okay, so with high beliefs for the binding, people accumulate more precautionary savings, so DT plus 1 becomes small. So with high beliefs, PT plus 1 becomes larger. Because PT plus 1 is larger, the economy can enjoy the more capital inflows, more borrowing DT plus 2. So with higher beliefs, current account reversal becomes less severe, and sudden stop crisis also becomes less severe because of the higher level of capital inflows. So here we model the occasionally binding collateral constraint as a regime switching problem. So we define the normal state and state of the current account reversal in the model. This is a state of non-binding state where collateral constraint is not binding and the collateral constraint is binding. So we introduce two states, N and B, non-binding and binding, and rewrite the slackness condition by introducing a switching parameter O. Switching parameter O takes 1 in the non-binding regime. So when it is 1, it is 0. It is 0. And when the collateral constraint is not binding, and in the binding regime, O takes 0, so this constraint holds with equality. And the switching between two regimes, N and B, is governed by the transition probabilities. And we assume that the switching from the probability of switching from N state to B state is given by these transition probabilities. And as this DNB increases, people believe that the binding regimes comes with high probabilities. The higher PTNB implies a higher beliefs for the binding. So this PTNB is assumed to depend on this D star. D star is a variable which captures the slackness of the collateral constraint. So we calibrate this transition probability so that this probability decreases as collateral constraint becomes more slack. So this PTNB is decreasing in D star. And to do our experiment, we model the different beliefs. We say that this blue one is a baseline belief. We say this red one corresponds to the high beliefs. So under high beliefs, any given level of the slackness of collateral constraint, this PTNB becomes higher than the baseline case. It's the same for the low beliefs. So green one is for the low beliefs. So any given level of slackness of collateral constraint, this is probability must be lower than the baseline case. Yeah, so the first experiment is regime-specific IRF. So the situation is that binding of a collateral constraint or current account reversal is expected, but it does never happens. Okay, so we investigate the impulse response function adjustment to the negative income shock under different beliefs. So we consider the fall in the tradable endowment, and because this is by correlated, non-tradable endowment also falls. And under the green and blue one, so under low belief and low belief and baseline beliefs, following the income show, following the fall in the income, people borrow more, people increase the borrowing. To smooth consumption, so the fall in the tradable consumption becomes lower than the fall in the tradable endowment. And the current account deteriorate. So this is what the typical intertemporal theory of current account suggests. Under the high beliefs, that one, adjustment becomes opposite, and the borrowing decreases, and the current account improves, and the tradable consumption falls more than the tradable endowment. So as a result, GDP and consumption falls more on impact. And the conclusion of this exercise is that with high beliefs, the adjustment, the reaction to the shock becomes higher, and the economy becomes more volatile. So it seems that higher beliefs is bad, but once collateral constraint binds, or once current account reversal comes, it's different. So here, now we allow the binding of collateral constraint, and we do some event analysis around a certain stop event or current account reversal event. So in the window at the period 0, constraint binds and current account reversal. So this period 0 is the time of current account reversal, or possibly the certain stop, period of certain stops. Constraint binds following the fall in the endowment, and period 0 constraint binds and borrowing falls, current account reversals, and the GDP consumption falls significantly. I mean, just a significant fall in the GDP and the consumption. But the severity of current account reversal and recession is different depending on the beliefs. So under high beliefs, the fall in the borrowing becomes the smallest, and the current account reversal is the most severe, because people have more incentive to save under high beliefs. People accumulate more precautionary saving. We can see that this here in the period of -1, the level of borrowing is the lowest under the high beliefs, because people save more. And because of this higher precautionary saving, once constraint binds, relative fall in the relative price is the smallest. And because of this higher price of collateral borrowing is higher, becomes higher, and under high beliefs, economy can still economy can enjoy some level of current capital inflows. So now we could explain that we can explain that high frequency of current account reversal. Under the high frequency of current account reversal, certain stop crisis becomes less severe, and with low frequency of current account reversal, the certain stop becomes more severe. Conclusion: we demonstrate how beliefs for losing access to the international financial market matters, and when people believe that capital inflow stops with high probability, they no longer smooth consumption using current account, and the economy becomes more volatile. But once current account reversal comes, the higher beliefs and the high precautionary saving mitigates the effect of this stop of capital inflows. Thank you very much.
Thank you very much. From my perspective, you are perfectly on time. And any questions from the audience? You see anyone? Yes.
So you showed us like a nice blue, green, and red dots pictures. Is there any other way to kind of characterize probability of current account reversals in the data? Then it's going to be kind of really nice to see that, okay, maybe the probability goes up, and just like what you say at the beginning, seems to be sort of kind of forcing us to believe your story, but it's going to be better to have kind of more objectively showing, what you want to say, I guess.
Maybe we can show that like a correlation between frequency of current account reversal and frequency of sudden stop, or the severity of GDP falls, right? Yeah. But I'm not sure, because sudden stop is a inherently rare event.
I see.
So there are not a lot of samples.
Right, thank you.
Thank you very much. Any online questions? Yes? Okay.
Hello, thank you. And one online question: why is the interest rate fixed? How are bonds balanced? How is bond balance keeping someone? How is bonds balance keeping each bond issued by someone should be bought by someone else? Okay, how is the bonds balanced?
The answer is because this is a small open economy model. Yeah.
Okay. Thank you, that's all.
So thank you very much again for the presentation. And this concludes this session, and we are nearly in time for lunch.